Hello. In this third video about instance member variables, I'll examine DrawingApp 1.1 from a different angle. Namely, I'll dive under the hood in order to hopefully give you a feel of what is happening as well in the memory areas of the Java virtual machine when the application is launched. The code I'll examine is what we've implemented during the hands-on. Two files. First of all, the rectangle class definition, in which we see the definition of our four public properties, x, y, height, and width. And we call this rectangle.java the definition file. The second file is DrawingApp.java, in which we implement the client or the test code, the code that is using the rectangle class. We see two instantiations. The first one for rectangle, after which I'll assign a few values to the properties of the object, and an instantiation for rectangle 2, for which I assign some different values. Let's see what this looks like in the memory areas. For those of you who are not familiar with concepts like method area, stack, heap, I advise you to first watch some of the videos of my other playlist, Stack and Heap Fundamentals. So in this screen I'm going to execute statements one by one and show you what effect each statement has in the stack and heap memory areas of the JVM. So let's start with the first statement. This statement can be split in three parts. First of all, the declaration of the reference variable rect1 results in allocation of that variable on the stack with a label rect1. On the right hand side we're going to create the object. Create an instance of the rectangle class using the new keyword. That has an effect on the heap, and memory will be allocated. And how big is the object? Well, class rectangle has four properties, as we've seen. Four instance data members, x, y, height, and width, all of type integer. And so for each data member, space will be allocated in the object on the heap. X, y, height, and width. The heap here assumes a width of 32 bits, which is the size of an integer. The object is located at some fictional address, 1000 in this case, expressed in hexadecimal notation. The third part is the assignment. The value obtained at the right hand side is assigned to the variable located at the left hand side. So in our case, the value of 1000, because that's the result of the new rectangle, that value will be assigned to the content of rect1. And now we have rect1 containing the address of an object on the heap, and so we say that it refers to, or it points to, and in C and C++ we use the term pointers, but it means the same thing. So rect1 refers to an object that is located on the heap at address 1000. Rect1 is a reference variable. A variable that is of type a class, in our case a rectangle, will result in a reference variable being allocated on the stack, and its sole purpose is to contain an address of an object, the object being located on the heap, or null, which then means that the reference variable doesn't refer to any object. Note as well that the default values of integer member variables is 0. Now we're going to assign some values to the individual properties. rect1.x is 10. rect1.x, we start with the rect1. Its content is address 1000. The dot means look at what is located at address 1000, or dereference rect1. And so following the arrow, we have now access to the object at address 1000. What do we want to do? We want to assign the value of 10 to the property x. And so the x field will be assigned with that value. Similar for rect1.y is 20, rect1.height is 100, and rect1.width is 200. Voila. Let's have a look at the second object that we create. Very similar. The only difference is that, well, we create a new reference variable, rect2, so at a new position on the stack, and then a new object is created on the heap at some fictional address, in my case 2000, and then the assignment will assign the value of 2000 to rectangle2 variable, so this one. And here we see that Rectangle 2 refers now to a different object with its own x, y, height and width data members. So both objects have the same structure, but they live independently from each other. So if we then assign the value of 30 to rect2.x, so here again we start from rect2 address 2000, we're going to have a look at object at address 2000. What field do we want to use? The x field or instance data member, and assign the value of 30. rect2.y is 40, rect2.height is 300, and rect2.width is 400. I hope you have a better understanding now of what is happening when we instantiate an object and assign some values to the properties of the objects. Thank you for watching. Bye bye.